Good morning. Welcome to another edition of Chemistry on the Fly with Mr. F. Today we're going to be talking about 5.50 balancing equations, and this is going to be part one of a two-part series. Okay, we've already seen some chemical reactions. We talked about hydrogen gas in a balloon and oxygen in the atmosphere, and we add a little flame and we create water. Now, how did we do that? Well, we had a chemical reaction that actually occurred. And the question, though, is how much water did we actually make? Well, that's where we're going to have to go to some laws. We have a law in science called the conservation of mass. So what does that mean? That mass cannot be created or destroyed. So what does that mean to us? We must have the same number and kind of atoms before and after a reaction. All right, the first thing we need to do is to figure out some of the numbers. I think you know this, but we're going to go through it anyway. So we're going to look at carbon dioxide. So here's a carbon dioxide molecule, and we see that the C stands for carbon. That's good. We see that the O stands for oxygen. I think we knew that too. But the 2, some people get a little confused with the 2. This actually has a name, and it's called a subscript. And what that means is it denotes the number of atoms of the element before on the compound. So, before it in the compound. So, the subscript is telling me that I have 2 oxygens. Now, notice that it belongs to the oxygen and not to the carbon. Some students in the past have figured out that, or thought that 2 belonged to the oxygen and the carbon, but in this case it really only belongs to the oxygen. Now, the carbon only has nothing in it. Now, scientists are kind of lazy, so if they don't write something, it often means a 1. So, when we look at this, we have no subscript on the carbon, but that just means that it's a 1. It still means that there's 1 there, but again, scientists are a little lazy and they decide not to write stuff that they don't have to. So let's look and see if that's actually the case. So there's my center carbon, and I do in fact have 2 oxygens. That's cool. So that 2 at the bottom of the oxygen is called the subscript. Now, if we wanted to change the quantity of these carbon dioxides, I could put a 3 in front, and this actually has a different name. This is called the coefficient. Now, the coefficient tells me the quantity of the compound. So if I put a 3 in front of this carbon dioxide, I would actually be saying that I have 3 carbon dioxides. And just like before with our subscripts, the coefficient, if it's blank, it means the coefficient is 1. All right, so let's start trying to count how many carbons and how many oxygens we have. So the first thing we do is write down carbon, and I have 1 because it's blank. So a carbon is equal to 1. And let's look at the oxygen. The oxygen has 2, so we're going to put a 2 there. And then we see that we have 3. Now again, this 3 belongs to both the carbon and the oxygen. So when I write this down, I have to write down times 3. Remember, this is saying that I have 3 of those. So if I had 3 oranges, I would multiply it by 3. Okay, so I have a 3 there. Now let's count. 1, 2, 3 carbons, check. And I should have 6 oxygens. There's 4, 5, and 6 oxygens. So we are good. Now, let's look at a compound that's an ionic compound that's going to be a little bit more tricky. Okay, this one is called lead-4 nitrate. Now, this is an ionic compound, and you see that it has lead in it, and then it also has a polyatomic ion, nitrate. All right, so let's look and see what this looks like. So, I have a lead nitrate molecule. You'll see that I have a big old lead in the middle. And then I have 4 nitrates. Now that 4 in the lead 4 tells me that lead is going to give up 4 of its valence electrons. So the nitrates are going to come around and take them because this is an ionic compound, so they're going to steal those electrons. Now the nitrate is a nitrogen, which I'm showing is green here, and then 3 oxygens. So that's what that looks like. Now, let's go put a coefficient in. Let's say that I have 2 of them. So there's 2 of our lead 4 nitrates. And we need to figure out how many of each of these things we have. So let's look at the lead first. So I have a coefficient of 1 because it's blank. So I'm going to write that down. And then this is one of the tricks that we're going to use when we balance. So the nitrate, we're going to treat this just as an element. So we're going to write nitrate from the top. We're going to write it on the bottom as the whole thing. And then we're going to look just outside the parentheses, and I have 4. So I'm going to say my nitrate is 4. Now this saves us a lot of trouble, so we don't have to keep track of all of our extra oxygens and all of our extra nitrogens in this case. We just have to keep track of the nitrate as a whole. And it really is going to save us a lot of trouble later on. All right, so now that we've figured everything out, we have 2 of those. So let's see, we need to multiply both things by 2. So I have lead of 1 times 2 is 2, and my nitrate is going to be 4 times 2, or 8. So let's do some counting, and let's see where we're at. So 1, 2 lead, so that's good. And then I should have 8 nitrates. So there's 3, 4, 5, 6, 7, and 8. So we are in good shape. All right, so we've got to come up with some balancing rules. Now, everything has rules, but we've got to figure some balancing rules. So the first rule is that we cannot change the subscript. Let me say that again. We cannot change the subscript. So if I had water, okay, there's my water, one oxygen, 2 hydrogens, and for some reason it didn't match for me. So I can't go and change it to a hydroxide ion, or which would mean I would take away a hydrogen. Can't do that. Or the that's the hydronium ion, where I can add a hydrogen. So I can't do that. If I'm talking about water, it's H2O. It's not OH or H3O or H2O2, which is another thing completely. These are all different chemicals and they all have different properties. So we can't go changing the subscripts, like in this case, just changing the number of hydrogens. Doesn't work. But we can change the coefficients. So if I said I had 3 waters, I would put 3 waters. So it would be 3 H2O. So I can only change the coefficients, but I cannot change the subscripts. Okay, here's a couple of balancing tips. Now I'm going to give you 2 tips right now, but we're going to be adding to this list a little bit. So the first tip is that we treat polyatomic ions as elements. So just like I did in the last example with the lead 4 nitrate, I took the nitrate and instead of separating it out into nitrogen atoms and oxygen atoms, I just kept it as a nitrate and kept it in parentheses. Now I will always put it in parentheses so you can see it. Some people don't always do that, but I will do that for you. Okay, so that's our big balancing, one of our first balancing tips. The next balancing tip is we often save the oxygen for last. Now that might not seem like a big deal right now, but we're going to save the oxygen, balancing that one for last. Now you can see that I only have 2 so far, but we're going to be adding to this tip list as we go. All right, now we're finally going to get into actual balancing of equations. So here's our H2O. H2 plus O2 is going to yield H2O. Okay, this one had the explosion earlier in the video. Okay, so what are we seeing? We have 2 hydrogens, 2 oxygens, and I'm yielding 1 water, which has 1 oxygen and 2 hydrogens. So we're going to go through some steps. I'm going to give you some tips and some steps, and these are the steps that have worked really well for my students in the past. So the first thing is we're going to draw a line down the middle. That line down the middle is going to tell us that we have our reactants on one side of the line and our products on the other side of the line. So the next thing we do is identify the elements. I have H and O, H for hydrogen, O for oxygen, and we're going to put them in the same order on the product side. Then I have to identify the quantity. So how many hydrogens and how many oxygens do I have initially? So we have 2 and 2. Where do those 2's come from? Well, the 2 comes from here, from that 2, and for the hydrogen and for the oxygen, we also have that 2. Now, that's the reactant side. Let's look at this, do the same thing on the product side. So I have 2 hydrogens and 1 oxygen. Where do those numbers come from? Well, there's the 2 for the hydrogen, and there is the 1 for the oxygen. So the next thing we have to do is check to see if we are balanced. Now, sometimes reactions are balanced, but what does balance mean? This goes back to meaning that I have the same number of hydrogen and oxygen atoms on the reactant side as I have on the product side. So normally I ask my friends, my students to do this, but today we're going to have to bring in some other friends since you're not here with me. So we can see that our hydrogen is balanced. I have 2 on the reactant side, 2 on the product side, and we look at the oxygens. Now I have 2 on the reactant side, but I only have 1 on the product side. Now, again, since I don't have my students in front of me, I brought some friends in, some friend memes. And let's just bring some in. So what do you think, Joey? Nope, I agree with you. I don't think that is balanced. All right, so let's see what we've got to do next. Let's keep with our list. All right, so let's try again here. So the next thing we're going to do is we're going to change our coefficients or multiply our coefficients. So what does that mean? Well, I have 1 oxygen on the product side and 2 on the reactant side. So what I can do is I can change the coefficient of the oxygen, multiplying it by 2 to make it equal to 2 on the reactant side. That's nice. But I have to do a couple more things. So I take that 2 and I move it up to my equation, put it in that blank space. That means that I have 2 waters. So there's my second water. Well, what also has to multiply out, since that 2 belongs to the oxygen and to the hydrogen, I have to multiply the hydrogen by 2, since that 2 belongs to both. Okay, a lot of my students miss that. They'll put a 2 up top, but they forget that it has to multiply the whole compound. So we need to check and see if we're balanced again. That's our next step. All right, my oxygens are balanced, yes. Okay, but my hydrogens are not. I have 2 on the reaction side and 4 on the product side. Phoebe, what do you think about that? No, yeah, she was always a little dramatic. All right, so no for Phoebe. Okay. All right, so let's continue. We have to go back to step number 5. All right, so we're now going to do the same thing. I have 4 hydrogens on the product side and only 2 on the reaction side, so I'm going to multiply that by 2. Put a 2 there, put a 2 here. Now, that 2 does not belong to the oxygen, it only belongs to the hydrogen. So we then add another pair of hydrogen atoms. And what do you think, Chandler? I agree with you. We're on to something. I agree. Thank you. All right, so let's go and let's check to see if we're balanced. Rachel, she says, please be right. Well, guess what? I think we're going to be, but let's check. Okay, so we check our hydrogens, they check. We check our oxygens 2 and 2, and they check. And let's go back to Joey. What do you think, Joey? Yep, I think they do balance. What do you think, Phoebe? Phoebe agrees as well. So I think we're in good shape here. All right. So this is our step. Okay, we're going to go through our steps again. So the first step was to draw a line between the product side and the reactant side. Then we identified the elements. We had our hydrogen and oxygen, in this case, on the reactant and on the product side. Then we identified our quantities, which means that we figured out that we had 2 on the reactant side, 2 hydrogens on the reactant side, two oxygens on the reactant side, and we had 2 hydrogens and only 1 oxygen on the product side. Then we checked to see if they were balanced, and they were not, so then we had to start changing our coefficients. And in the first case, what we did was we multiplied the water by 2. And then we checked to see if they were balanced, and they weren't, so we had to go back and try number 5. Now, that's our 7 steps, and eventually we do get to the point where we're balanced. Now, Ross, I need some help here. Okay, so what do we got to do with balancing equations? We've got to practice, practice, practice. We're going to practice a lot more in our lesson tomorrow. So, as always, it's Chemistry on the Fly with Mr. F, and as always, have a great day.